Yo, yo, Algebrainiacs! Welcome to the Johnson Kendall Video Hour.
But it's not an hour.
Yeah, okay, that's what you say, but we'll see. Alright, today we're going to talk about absolute value. We're going to build your vocabulary here.
Absolute value.
So, definition. It's the real number is its distance from zero. So look at the little example over here. We have positive 2, negative 2, but they're both just plain old 2 from 0.
What does that mean?
Well, it means if x is positive, then the absolute value of x is still x. But even if it's negative, the absolute value
Is the positive.
is the positive of it.
Yeah.
But if x is negative, then
It's confusing.
it's going to be the opposite.
Yeah, it's confusing. They mean if this is a negative number, then this is the opposite of that, which
Right.
is positive 5.
So the definition is a little misleading, but
It's
just
always
know
positive.
it's always positive.
Oh, and I use 5. I think they use 5 too.
Look at that.
Oh.
Ingenious. All right.
So that's an absolute value of a number. We're doing absolute value equations.
Aha. So this changes things a little bit. Okay, to solve an equation, we got some steps here for you. First thing you do is isolate the absolute value bars. So they are already isolated in this problem. They're all by themselves.
On one side of the equal sign.
Right.
All right, next.
Now we got to make two equations because we have to accommodate for the positive and the negative.
Yeah, so if we have 3x plus 2, that could be equal to 7, or 3x plus 2 could be equal to negative 7. So think about an easy version. If we told you the absolute value of x is 5, x could be 5, or x could be negative 5.
So we have to write both of those down.
Right, so you take the things from inside the absolute value and you do not change that sign. So it was 3x plus 2 and it was 3x plus 2 no matter what. The only thing that changed was the right-hand side of the equal sign
And now it becomes two easy little equations
that we solved.
that we solve.
How did we solve the first one?
So subtract 2. 3x equals 5. Divide by 3, and we get 5/3.
Leave it as a fraction?
Yes,
Because fractions
Fractions
are
are friends.
All right, the other one, same steps. We're going to get different numbers. 3x equals,
Negative
and
9.
then divide. That's equal to negative 3. There is one other step. You must.
Always check.
Okay, this is something, it's not like be careful and check. It's possible, we'll get into this a little bit later, that you'll get what are called extraneous solutions. So when you check, what you want to do is take the number that you got for your solution. I just put it off to the side so I know what I'm checking. You go back to the original problem, and that's very important. You use the one that was written in the textbook or on the test or whatever it might be. 3x plus 2 is in the absolute value. So we're going to do 3 times 5/3 plus 2, and we want to see if it's equal to the answer on the other side.
Gotcha.
All right, help me out with these fractions,
Take it
Kendra.
over 1, then multiply straight across. 15/3.
Which is the
or,
same as-
Yep, cancel those.
Yeah, that's 5 plus 2.
So that one checks.
Is it equal to 7? I think it is.
Absolutely.
Okay, so
Ah.
this guy works.
Absolutely.
All right, negative 3 in the little box here. 3 times negative 3. We're going to add 2, and we want to know, is that equal to 7?
So negative 9 plus 2 is negative 7.
But, whoops,
Oops.
and then this is an absolute value of that. So now is that true?
Which certainly does.
Okay,
Check.
so that means that we got 2 solutions. There's going to be some problems in this section where you have 2 solutions. Sometimes you will only get 1 solution, and it is possible to get no solutions. So nothing checks.
Okay, multi-step. We gotta do more than one thing. So
Step 1 was what?
we need to isolate that absolute value bar thing. So we got a plus 5 with it, so let's subtract 5.
And we're getting rid of that before the 2, right?
Right.
Okay. So 2 absolute value of 3x minus 1 equals 28. Then what?
And then I still
Can I
have a
distribute?
No, those absolute value bars are like prison bars. You may not go through them. Not with a negative sign, not with a number, so get rid of the 2 by dividing.
So now we have absolute value of 3x minus 1 equals 14. Absolute value is now isolated. What's the next step?
Set it up with both the plus and minus.
So does this change to a plus?
Nope, we leave the absolute stuff alone.
Okay,
Only the 14 changes.
negative 14. All right. How
So
do we
move
go?
the 1, you get 15.
Then what?
Divide by
And
3.
we get
5.
all right. And then for this one, add
Add
1. This time,
Negative 13. Okay. And gotta check. But for time's sake, we're not going to check this one.
yeah, if it were your assignment, you would need to check. We're going to cheat a little bit.
Yeah,
Those check. We showed our work.
that's right. Okay, extraneous, another new vocabulary word.
What
That
is-
means it's extra. It doesn't work. It's a solution that for some reason snuck in there, but it doesn't really work.
So it's an answer we're going to come up with, but when you check,
It won't
it
make
won't work.
sense.
Oh, and I noticed we've got variables on both sides.
Ooh, and this is a lot of times when the extraneous one shows up. So be aware of that when you see X on both sides, this might be the case.
Step 1 is to
Isolate, we did that.
That is alone. So now we split it.
Okay, so 2x plus 3 equals,
Okay.
now, we have to take the positive first, so that's easy.
And for positive, just leave it how it was.
Yeah,
Okay, and then remember we're leaving this side alone. 2x plus 3 is never going to change. But
now we have to do negative of that whole side, so negative 3x and negative 2.
what if this were to be a minus sign?
Then it would change to plus.
Okay, so you have to change the sign of everything that's on the right-hand side.
Correct.
All right,
All right, now solve it like you would a normal equation. So on the left problem here, I'll subtract 2x.
smaller bundle of bananas.
Yep.
All right, that's x plus 2 equals 3.
Now subtract 2, and we get 1.
All right, x is equal to 1.
Good.
Okay,
Same, let's see, add 3 now, so we get 5x. And subtract 3. 5x equals negative 5, which means x equals negative 1. Okay, let's check.
1 first.
Okay,
Okay, so we got to substitute on both sides. 2 times 1 plus 3 in an absolute value, is it equal to 3 times 1 plus 2?
2 times 1 is 2, plus 3 is 5.
5. That's an absolute value, not
Yeah.
15. We want to know, is it equal to this?
5, absolutely.
All right, this guy works.
Good.
All
Negative
right.
1, so 2 times negative 1. I like your question mark above the equal sign,
Because
by
we
the
don't
way.
know.
Right? We can't
it
say
equal to?
equal because we don't know.
Is it equal?
So negative 2 plus 3 is 1.
Look at that.
Looks like 3. Is that equal to negative 3 plus 2?
That's negative 1.
Oh.
You might be tempted, but that is not true.
Nope, because absolute value of 1 is 1, not negative 1. So we got an extraneous solution there.
So we've discovered negative 1 is an extraneous solution. Does that mean I should include this on my
No,
test or quiz?
no.
Okay, that is not an answer. You do not need to include it at all. This is one of the problems that you would just have one solution.
Nice.
All right, I think this is our last problem. We're actually taking lesson 1/6 and splitting it into 2 different days. So
Otherwise, your notes would be an hour.
Yeah, that's right.
Whoopsie.
There she goes.
Disappeared.
All right, here we go.
Isolate. Okay, that 4 is bothering me. Let's get it out of there.
But how?
Well, it's a positive 4, so combine it with a negative 4 to make it go to 0.
And I can't add those together?
Uh-uh.
Okay, because the 2 is attached by multiplication.
Right.
All right, so subtract.
Okay, negative 2 on the outside equals negative 9. Now you can get rid of that negative 2. Okay. Do we want to change that to fraction or to decimals or anything right now, or leave it as a 9/2?
I don't know.
I think fractions are our friends, so let's leave it for a while.
I would rather be fractions, but I thought you might.
No,
Okay.
no,
All right.
I would leave it. All right, so now we set up the 2, 1 plus, 1 minus.
So x plus 9 equals 9 halves. Notice there's no more absolute values when you split. It's like these two bars turn into the arrows.
Oh, cool. That
Okay.
looks like a tree with roots now. Yeah, this is the tree of knowledge. People, okay, we're getting some knowledge. Now set it equal to the opposite or negative of that.
Okay, oh no, I have to add fractions.
Oh dear.
Subtracting 9. All right, what do you
So-
think the best way to do this is? 9 halves minus 9.
18 halves.
Oh yeah, you do that thing. Okay, we'll show our work here. She is multiplying by a useful form of 1. So that means you multiply the top and the bottom. So 9 halves minus 18 halves. How many halves is that?
Negative 9 halves.
Okay, that's one of the possible solutions. I probably shouldn't circle yet. 'cause
Not yet.
we're not sure. Okay, this time we're going to subtract 9 from negative 9 halves.
So same deal, but-
this is negative. So negative 9 halves minus 18 halves. Now we're going more negative
Negative 27 halves.
over 2.
Mm,
Wait, are we going to get fractions like this?
maybe.
Oh man, man, oh man, oh man.
Fractions are friends. Don't.
Okay, we have to check them. So negative 9 halves and negative 27 halves. There it is. Do you think we need to check here, or can I check in the absolute value one?
The original.
Okay, so
Because what if you made a mistake somewhere along the way too?
yeah,
It might show up.
so I'm gonna do negative 9 halves first.
Okay.
Excuse me. 4 minus 2 times the absolute value of x. Oops, we know
Let's
x.
plug it in. Yep.
We know x.
Plug it in. Plug it in.
Minus 9 halves plus 9. And we want to know if it's equal to negative 5. Holy cow.
Holy camole.
Holy camole.
So let's do the inside first.
This is 18 halves. We've already done that twice.
Right. So
Okay.
we know negative 9 and 18 is positive 9
9 halves. In an absolute value, we're going to multiply it by negative 2.
So take the absolute value first.
That's 9 halves.
So 9 halves times 2 over 1.
That's going to be negative 9.
Right. Because we can cancel those 2's.
Okay. Is that equal to negative 5?
Absolutely.
Okay, that means that this guy worked.
Sweet.
All right, now we're going to do negative 27 halves.
I like how you put it up in that little press box thingy.
It's a reminder for
It
me.
helps. Yep, it helps.
4 minus 2 minus 27 halves this time. And I'm just going to change it right now. We're changing 9 to 18 halves. See if that is equal to negative 5. Leave all this junk alone. How many halves we got in there?
Negative 9 halves.
Okay, negative 9 halves.
But absolute value
Oh,
of
yeah,
that
that's
is
right.
positive.
And then we're going to multiply it by negative 2. So then it's going to go back to a negative anyway, right?
Right.
Is that equal to negative 5?
Sure is.
So they both work.
Excellent.
Okay, can I mention one more thing?
I think so.
I think you're pretty smart.
Oh boy.
And I think you know the answer without doing any math at all.
Ooh. Absolute value equaling a negative. That's not. You're tricking me.
Okay, so you are going to see this every once in a while. I know without doing any math that this problem has no solution. And we know that because the absolute value is isolated on the left and there's a negative on the other side.
And that can't be. Absolute values are always positive.
So if you notice that right away, you don't have to do the whole problem, just write no solution. If you don't notice it, what's going to happen is you're going to go through and get your 2 answers, but then what?
And you'll put them back in and neither will work.
Yeah, they'll both be extraneous.
Yep.
Cool.
All right, good job.
See ya.
One of them